Hi, my name is Syed Naveed Hamad. I would like to thanks to LJMU faculties for giving me opportunity to present my final thesis report. And my title is Innovative Approaches to the Cold Start Challenge in Fashion E-commerce. Now let's look into the agenda of this video presentation. On the first, we'll be discussing about the introduction and the background of the study, following literature review, then aim and objectives, then research methodology, and then result and limitations, and final conclusion and future recommendations. Let's look into the introduction part. Now let us see what is mean by cold start problem. The cold start problem refers to a challenge faced by recommendation systems, particularly in e-commerce, when there is lack of historical data about new users or new products. In such scenarios, the system struggle to make accurate or personalized recommendations due to the absence of prior user interactions or product performance data. This issue is especially pertinent in a dynamic field like fashion e-commerce, where new products are frequently introduced and consumer preferences can rapidly evolve. Addressing the cold start problem is crucial for enhancing user experience and the effectiveness of recommendation system. Now let us see what is mean by item cold start and user cold start. Hence, there are two types of cold start problem which we define as item cold start and user cold start. Now, what is mean by item cold start? This occurs when new products are added to the system. Without historical data on these items, the system faces difficulty in accurately recommending them to users. The second is user cold start. This challenge arises with new users when the lack of previous interaction data makes it hard for the system to understand the user's preferences and suggest relevant product or content. Now, here in this thesis, we have specifically focused on addressing the item cold start problem in the realm of fashion e-commerce. Our work involves developing strategies and employing advanced techniques to effectively recommend new products for which no prior user interaction data is available. This focus is critical for enhancing the user experience and the success of new product introduction in the dynamic fashion industry. Now let us see the background of this study. The first is evolution of fashion e-commerce, and the second is significance of recommendation systems. The third is challenges in recommendation accuracy, and the last but not the least, technological advancement and solutions. Now let us deep dive into all these four backgrounds. The first is evolution of fashion e-commerce. Fashion e-commerce has evolved significantly with the advent of digitalization, transforming the traditional fashion retail landscape. E-commerce now stands as a central platform within the industry, revolutionizing the way fashion products are assessed, explored, and purchased by consumer by worldwide. Now, what does that mean? Imagine a time when fashion retail was confined to brick and mortar stores. Fast forward to today, and we will witness a dramatic shift. Digitalization has propelled fashion e commerce to the storefront, completely revolutionizing how we interact with fashion today. It's not just about the physical purchase, it's an entire digital experience where consumers from all corners of the world can explore and buy fashion product within just a click. Now let's look into the significance of recommendation system. Recommendation systems have become increasingly integral to the success of fashion e-commerce, fundamentally enhancing the customer experience. They play a pivotal role in driving sales by personalizing the shopping journey, curating product selections tailored to individual preferences, and streamlining the discovery of new fashion item consumers globally. The third is challenges in recommendation accuracy. Before going to the challenge in accuracy, we just look into it what is mean by the significance of recommendation system. Now think about the last time we have shopped online. How did we find what we were looking for? This is where recommendation systems come into play. These systems are the unsung heroes of fashion e-commerce, working behind the scene to craft a personalized shopping journey. They analyze your preferences, curate product selections, and significantly impact sales by making sure and the right product find their way to the right customers. This is how it worked. And now we'll move on to the challenges in recommendation accuracy. Current recommendation system in fashion e-commerce face complex challenges, particularly when it comes to accurately predicting user preferences and determining the potential success of new fashion items. These systems must navigate a landscape of rapidly changing trends and diverse consumers' tastes, making the task of aligning product offerings with the customer desire both critical and demanding. Now let's see what does that mean. Here, what we are discussing, it is not a smooth sailing. These recommendation system face a plenty of challenges, especially when new product items, which is mean a new fashion items, enter the market without any previous user data. How do we predict which items will be a hit in those markets? How do we cater to the diverse tastes of fashion forward customers? These are critical questions that recommendation systems strive to answer amidst rapidly changing trends and a global consumer base. Now, the last is technological advancements and solutions. The exploration of advancements in artificial intelligence, machine learning, and data analytics has opened new frontiers for enhancing recommendation system in e-commerce. These technologies have been employed to refine the precision of product suggestions and enabling a more sophisticated understanding of consumer behavior and preferences. As a result, e-commerce platform can offer a highly personalized shopping experience and anticipating consumer needs and streamlining the path to purchase. Now let's move on to the problem statement. This study aims to improve recommendation system accuracy, especially for new product lacking historical data, and recognizes their vital significance in fashion e-commerce. In order to successfully launch new fashion items into the market and make sure they follow customer trend and preferences, we want to improve these process. This will enhance the shopping experience and faster business expansion in the ever evolving fashion sector. Now, what is the benefits of this? It will improve the product discovery. It facilitates accurate recommendations of new fashion items, enhancing discoverability and user experience. Data driven inventory management. It assists retailers and wholesalers as well in managing inventory by predicting new item popularity. Personalization from day one. It offers personalized experience for users even with new inventory, increasing customer satisfaction and loyalty. Trend alignment ensures new products it will align with emerging trends, leveraging real-time data for better market responsive. Business growth, it supports growth by improving the match between new fashion offerings and consumer preferences, driving sales and reducing stock redundancies. Now let us look onto aim and objectives of this study. The primary objective of this study is to construct a proficient framework for mitigating the cold start predicament encountered by consumers within the realm of fashion e-commerce recommendation systems. The objective is to optimize user involvement and conversion rates for those who are new or have limited activity by offering precise and tailored recommendations. There are four objectives which we have worked on this thesis. The first is to analyze product trend and preferences. The second is to develop predictive models for product recommendations, and the third is to enhance product discovery and personalization. And the last is to contribute to e-commerce recommendation system literature. Now let us look what is mean by the first objective, which is to analyze product trends and preferences. This study aims to analyze and identify the latent patterns and trends in the popularity of products, price strategies, and color preferences, and brand perceptions within the fashion e-commerce industry. The second is which is to develop predictive models for product recommendations. This study aims to develop and assess machine learning models that utilize many product features including price, color, brand, and ratings in order to forecast the success and relevance of products. The third is to enhance product discovery and personalization. This study aims to propose effective ways for fashion e-commerce platforms to successfully launch new goods and customize product suggestions for new customers, thereby enhancing user engagement and satisfaction. The last is to contribute e-commerce recommendation system literature. This inquiry seeks to clarify perspective and approaches that possess applicability throughout the wider domain of e-commerce. These are our aims and objectives. Now let's move on to the methodology section. In methodology section, we have defined what methodology we have used for model building. The first is our data selection. The second is the data pre-processing, which is required, which is must and required for building all the machine learning model. And the third is exploratory data analysis. In exploratory data analysis, we have done univariate analysis and we have done bivariate analysis as well. And in the left hand side, we can see the picture of our flowchart of our proposed methodology. And the fourth point, we have done a feature selection. The feature selection is must and a very critical phase of the model building, where we need to select the features, the category features, and as well as the numerical features. Post feature selection, it is the next step, which is our data transformation. In data transformation, we have transformed the two types of data. One it is categorical data and the other is numerical data. For categorical variables, we have used one hot encoder as seen in the image, and for numerical variables, we have used standard scalar as seen in this flowchart. Then moving forward, after data transformation, there is a crucial part of model building. It is a train and test split. We have trained and we have splitted the data in train and test. In train, we have used 80% of the data to train the model, and in test split, we have used 20% to test the data based on the trained model. Then comes the model building. We have used two types of model. We have used four types of models. One without hyperparameter tuning, and the second is with a hyperparameter tuning. Here, as seen in the flow chart, we have used logistic regression, random forest classifier, gradient boosting classifier, and support vector classifier. All these four models have tuned with hyperparameter tuning, and as also without hyperparameter tuning, and we have evaluated with the evaluation metrics like precision, recall, accuracy, and FN score. Now we'll look into the results and limitations. In results and limitations, this is the agenda which we will be looking going forward. One, what is the results of exploratory data analysis and the final results of our models before hyperparameter tuning, and final results of our models after hyperparameter tuning, and the result summary. Then the last is the limitations of in this thesis. Now here we are seeing the results of top 10 brands. The chart which is showed in the right hand side displays the frequency of items for each brand, providing an understanding of which brand have the greatest number of listed products. The roaster brand boasts the largest assortment, comprising around 300 goods. Tokyo Talkies is the second most prominently featured brand with a product range exceeding 250 items. The next item on the list is Sassafras, which has a count slightly exceeding 200. Anok and Mango have comparable quantities, with Anok having a little advantage. Both brands are priced somewhat below 200. Rest all brands have less than 150 products. Here we have found that the top brand is roasted in terms of products. Now we look into what are the top 10 colors in our dataset. Black is the predominant hue with a count over 800 goods, making it the most popular. The color blue ranks as the second most prevalent with a count slightly below 800. Pink and green are the subsequent colors, with pink having a little greater tally than green, both about reaching the 600 threshold. The numbers for navy blue and white are nearly 600 with similar values. The count of red is marginally lower than that of white and navy blue, while purple falls in between a count ranging from around 400 to 500. Among the top 10, gray, maroon, and beige have the smallest frequencies. Gray has a slightly higher count than maroon, where beige color have the lowest count, which is approximately 200. Now let's look into the model. Now let's look into the models, the evaluation models, and the results which we have got from all these four models. The right hand side table describes the models which we have used for model building in this thesis, and what is the evaluation metrics which we have used, and what is the output which we have got from those metrics. Now let's see the logistic regression for an example. The model logistic regression and the metrics which we have used for evaluating purpose, it's your accuracy, precision, recall, and F1 score. The accuracy which we have got here is 0.692 and precision is 0.7078 and the recall is 0.9451 and F1 score is 0.8094. So this is an example like how the model which we have used and the metrics which we have used for evaluating purpose and the output which we have got from the respective models. Out of the four models that were assessed, the support that were assessed, the SVC model, that is which the support vector classifier obtains the highest F1 score of 0.8189, indicating that indicating that it possesses the most optimal equilibrium between precision and recall. These findings indicate that the support vector classifier is a most efficient model in balancing the trade-off between the real positive rate and the accuracy of positive predictions among the models in this set, without any tunings to the hyperparameter. Now we'll move on to the models with hyperparameter tuning. And same as before, here in the right hand side, there is a tabular column where we can see all four models, their evaluation metrics, and their output. Here also, out of four models with hyperparameter tuning, support vector classifier performs well with a F1 score of 0.8199 among all other models. Now let's look on to the result summary. In exploratory data analysis result, our top brands is the chart which have been provided a detailed breakdown of product frequency across various brands, revealing insights into their respective market presence. The analysis highlighted that Roaster is the leading brand in terms of product listing, showcasing an extensive range of approximately 300 items. And in top color, the analysis of color popularity in products revealed that black is the most favorite color with an impressive count of over 800 items, making it in the leading choice. The final model result, the SVC model, both with and without hyperparameter tuning, consistently outperforms all other models in terms of F1 score, making it the top model. Now, this is the limitations of our thesis. One major constraint is the notable, which is the lack of user-specific data in our dataset. In the dataset utilized for the investigation, this presents a difficulty because conventional recommendation algorithms significantly depend on user data, such such as surfing habits and purchase history. Given the absence of user-specific data, this study emphasizes in redirected towards a product-centric approach rather than user-centric approach, leveraging the characteristics of the product to forecast its success and relevance. This approach may not comprehensively capture the subtleties of user preferences and behaviors. The cold start problem is especially prominent in fashion e-commerce because of the swift evolution of trends and the constant introduction of new products. The dynamic nature of fashion trend introduces intricacy to the recommendation process, as historical data may rapidly become obsolete and fail to accurately represent present trends. The rapid turnover of products in the fashion business leads to a continuous intake of new things, posing a challenge for conventional recommendation system to adjust and effectively endorse these new products. Now, these are our final conclusions of our study. This study aimed to tackle the cold start problem in fashion e-commerce recommendation system, namely by enhancing user engagement and conversion rate for new or minimal engaged users. The initial objectives of this study have been achieved to different extents, making significant contributions to both the practical aspects of our e-commerce and scholarly discussion. And below are the objectives which we have discussed in starting, and we have completely achieved our objectives in this study. The first is to analyze of product trends and preferences. The study sought to identify the intricate patterns in product trends, pricing strategies, and brand perceptions. To development of predictive model for product recommendations, developing and evaluating machine learning model to forecast the performance and relevance of product was a vital goal. Enhancement of product discovery and personalization. The objective of proposing strategies product launches for effective product launches and tailored suggestions for new clients was mainly accomplished. Contribution to e-commerce recommendation system literature. This study has enhanced the existing body of knowledge on e-commerce recommendation systems by offering innovative perspective and approaches. Now let us look on the future recommendations, which is six types of future recommendations. Let's deep dive into all six future recommendations. The first is enhancing real-time adaptability of recommendation systems. Here we are talking about using real-time data analytics. This means the system will constantly update itself based on what's trending right now, what people are buying, and what's going out of style. So every time we use it, we will get recommendations that are not just based on our taste but also on what's currently popular. This way, the recommendation we get are always relevant and personalized to what's happening in the fashion world at that moment. The second is expanding sources for trend analysis. Here we can aim to understand fashion trends and what consumers really want. To do this better, we can plan to look a lot more information from different places. Think about all the fashion posts and trends on social media or what's happening at big fashion events around the world. We can study how people shop for clothes in different regions. By bringing all this information together, we can get a full picture of fashion world as it keeps changing. This way we can make better predictions about what people might like to wear next. The third is advanced machine learning techniques for predictive modeling. Here we can more complex machine learning models. These aren't just any models, they are designed to handle really detailed data and predict how customers will behave. We can explore deep learning and neural networks. These are like brains of the computer world, and they could really change the game in recommending products. By using these methods, we believe we can make recommendation systems much smarter and more accurate in figuring out what people might want to buy next. And the fourth is personalization for diverse consumer segments. Here we can plan to take a closer look at how we can make shopping even more personal for different kinds of customers. We can think about how to develop detailed user profiles that consider a lot of different things like what cultural background someone comes from and how old they are and what kind of budget they have shopping. And by understanding these aspects, we can fine tune our recommendations. So, whether someone's a college student looking for affordable fashion or for someone who is into luxury brands, our system can suggest the perfect items for them. This way, everyone gets a shopping experience that tailored just for them. The fifth is sustainable and ethical recommendation practices. Here we can turn our attention to a really important issue, sustainability and ethics in fashion. Nowadays, a lot of people care about where their clothes come from and how they are made. So we can think about how online shopping platform can include this in their recommendations. Imagine if when we are looking to buy something, the system not only shows you what suits you, but also it shows the style, but also it will tells you if it's made in an ethical way or if it's eco-friendly. We want to explore how we can recommend products based on whether they follow ethical reproduction method or have good sustainability things and have good sustainability ratings as well. This way we can help people to make their choices that are good for them. And the last is longitude studies on consumer engagement. Here in future we can take a long term look how will personal recommendation system keep customer interested and loyal. We can plan to do research over a longer period to see how this works. Think about it, people taste changes, new trends come in, and what was popular last year might not be this year. So we want to understand how customer preferences change with time, and then we'll be discussing how these recommendation systems can keep up change along with them. By doing this, we can learn a lot by keeping customers happy and engaged with the brands they love, not just a short while but for years to come. Thank you all for taking the time to watch this presentation. I greatly appreciate your interest and attention. Your engagement and insights are invaluable to this research journey. Thanks again for your support and for being a part of this exploration in the fascinating world of fashion, e commerce, and technology. Thank you once again.